Okay, let's review the life cycle of the drone, meaning what are the ways in which you are able to control the drone? Let's pull down our instruction document here. Oops. Pull down our instruction document. Come on, instruction document. There we go. All right. We get our set up. So now working with the Drone World code, your job is to write code in mydronecontroller.java. Let's see where that is. Going over to Eclipse, you can go under reference and you can see my drone controller is right here. And that's the base class that we're working with and the class that you're going to modify. All right, this is an event-driven simulation, meaning that the simulator is going to be running the world and periodically it's going to call the methods in your class, in your controller class, when it wants to give you the opportunity to make decisions when different events occur. Your methods, when they're called, can do whatever calculations they want. They can store whatever information they need to store in instance variables, and then they return so that the simulation can continue. You may override any of the methods listed in Drone Controller Skeleton. So my drone controller is a descendant of Drone Controller Skeleton and inherits all the methods that are present there. Now, you don't have to implement them, but they're available for you, and we'll look at that in a second once we go through the life cycle. Study the mydronecontroller.java to understand the patterns of how it works. Typically, the way that your controller is going to communicate to the simulator where you want it to go, where the code wants the drone to go, is to call one of the methods in the simulator class to help the simulator guide your drone in the behavior that you want. So if you want your drone to go to a particular place, you call one of two methods. You call route drone, where you pass it the drone that you want to route and the place that you want it to go, or you call route drone with the drone that you want to route and the name of the place that you want to go as a string. I recommend using the place class instead. The other thing that you have to do is you have to announce to the passengers where your drone is going. And you can do that with one of three methods. The bottom one, set drone manifest, you pass it the drone that you're giving instructions to and one place where it's going. Or you can do set drone manifest with the drone you're controlling and one place where it's going, represented as a string. Or you can call set drone manifest with the drone and a number of places where it's planning on going. Now the thing is, every time you call one of these, whether it's route drone or set drone manifest, it doesn't add up on the previous ones. It erases your previous directions and replaces it with these directions. And so if early in your method you say route drone to In-N-Out, and then later in your method you say route drone to Westmont, it's not going to go both places. It's only going to go to the last place that you call after you return from your method that you're calling it from. Okay, now there are two different things here. There's a route drone and there's the set drone manifest, and those are different because you can tell a drone to go one place and you can tell your passengers you're going to a different place. So where your drone actually goes is based on what you pass into route drone, but where the passengers think you're going is what you leave in the drone manifest, and that's to enable you to do sophisticated algorithms if you want. Basically, the passengers board your drone based on what you've written in the manifest. So when you land, a passenger will get on your drone if that passenger wants to go to the place that's in your manifest. Or if you provide a set of places, any of the places in your set of manifest destinations. Okay, so where your drone is going and where you tell your passengers where you're going are two different things. Now, it makes sense that they wouldn't be totally different if you want to be successful, but they can be slightly different. Okay, if at any point you implement a method and it takes more than 10 real-world seconds to return, then the simulator is going to put your drone into a quarantine state, meaning that you've written bad code. For example, maybe you have an infinite while loop. After 10 seconds, the simulator is going to say something's gone wrong. It's going to shut down your drone, and your drone's going to be put in a quarantine mode. All right. We've looked at how to run the simulation. So let's see. So the next thing that I wanted to do is I wanted to connect the lifecycle to the code. There's a little bit more that I want to say about the lifecycle before we do that. And I'm going to jump down here in the instructions to a diagram that I've got. All right. This is the drone lifecycle. This describes all the different phases that the drone goes through and your opportunity to make instructions. Now, this is very complicated looking, but actually there's probably only one or two places where you want to intervene. So the way it works is that we start over here with the drone simulation start. And this method will be called on your controller, and you can do something at the beginning if you want. That drone then goes into a drone begin state, and then it goes into a drone embarking state, and then you get a method that's called drone embarking start, and you can do something if you want. When you return from that, the drone will embark a group of passengers, and it will start doing that, and then it'll end embarking a group of passengers. If there are more passengers to embark, it'll keep doing that in a loop until your drone is full or there are no more passengers, and then you'll get drone embarking end called. Then your drone will go into ascending mode. You'll get a drone ascending start call, and then a drone ascending end call. Then your drone will be in transit. You'll get a drone transit start call, and then you'll get a drone transiting call in between as your drone moves from 0 to 100% of its destination. Let's see, that one should be, there should be a loop on that because that's going to be called over and over again. And then you'll get to drone transiting end. When you're done transiting, then your drone will start descending. Its state will go to descending. It's descending start, descending end. Your drone will start disembarking. You'll do disembarking start. You'll disembark a group, end the group, keep looping that until everyone's disembarked. You'll be done disembarking completely. Then your drone will start recharging. You'll drone recharging start. You'll get progress along the way, drone recharging end. And then when you're sitting at a location, if you haven't told the drone where to go and it doesn't have instructions, it'll go into drone idling mode. In drone idling mode, I'm missing a parenthesis there. Drone idling mode is the primary place where you want to go to make your interventions from the beginning. That's the place that's easiest when you start with. And then finally, when the whole thing is over, you get drone simulation ending. You can see that there are arrows down after any of the function calls because you can end up in a drone behaving badly state, and you'll get that method call, and then you'll go into drone quarantine state, at which point your drone is out of the game. In later versions, when we do in transit, you can, the first round, we're not going to worry about this, but in later rounds, while you're transiting, you can run out of charge, at which point your drone will go into exploding, and then dying, and then dead, and your passengers on board will die as well. Okay. So let's connect that to the code.